Here's the review video for page 9. Again, my video tips, quiet place. Make sure you're listening and writing and practicing in the calculator. Pause and rewind. When you're asked to pause, please make sure you're trying the problems. Use the hints if you need, and bring in any questions that you have. Points as solutions. So, if a point is a solution, it must lie on the graph of the equation. If a point is a solution, when you plug it in, it must make the equation true. Okay, so let's look at the first one. It says if the point k negative 5 lies on the line whose equation is 3x plus y equals 7, then the value of k is what? So the first thing I'm going to do is I'm going to plug this point in. So instead of 3 times x, I'm going to replace x with my point's x value, which is k, plus y. Well, y is negative 5, and that should equal 7. Now I can solve this. So I'm going to add 5 to both sides. And I end up with 3k equals 12. Divide both sides by 3, and I get that k equals 4. So I think choice 4 is my solution, but I'm going to take that extra moment to check it in my calculator. So I'm going to add the page. I'm going to add a graph. Since y is not alone in my equation, I'm going to use a relation. 3x plus y equals 7. And I hit enter. So now I'm going to go to menu, trace, graph trace. And I think my x value is 4. So I'm going to type 4 in here. And I can see that 4, negative 5 is on the graph. So I do feel confident that 4 is the value of k. Let's try the next one. Which ordered pair does not represent a point on the graph of y equals 3x squared minus x plus 7? This was on an exam, and it gave a lot of people some difficulty in the calculator. So I wanted to make sure we went over this. I'm going to add a page. I'm going to add a new graph, and I'm going to type in my function. I don't need it to be a relation because it's f of x equals. So I've got 3x squared minus x plus 7. Now, first thing I notice is I do not see anything on my graph. If you look at these y values, you're going to notice they're quite high up. So one of the things you can do is you can come up here and double click on the number at the top of your y-axis. And I'm going to change that to something bigger than all those y values. I'm going to make it 30. And when I do that, I can see my graph much better. Now I'm going to go to menu 5, graph trace, and I'm going to start by entering that negative 1.5. And what I notice is I get 15.3 as the value of my point, which would make me think number 1 is not on the graph. However, the calculator is rounding the answers sometimes. So a second place you can go to double check and get a more accurate answer for your points is you can go to the table. Now, the problem with the table, whoops, is that it doesn't have negative 1.5 on it. We can fix that. So if you go to menu and you go to table, we can edit our table settings. The setting I want to change is instead of my table step being 1, meaning counting by ones, I want it to count by 0.5s. So I'm going to click OK. And now I can see that at negative 1.5, the value of my function is 15.25. So this point is on the graph. And now that my table is set by 0.5s, I can check 0.5. And at 0.5, it's 7.25. So that point is on the graph. 1.25, I cannot check. But while I'm here, I'm going to check 2.5. That's 23.25. So my suspicion is 3 is the answer. Here's how we'll fix this. I'm going to go to menu again, table, edit table settings. And instead of counting by 0.5, I'm going to count by 0.25. And now I can go to 1.25 and I can see that that Y value is definitely not 10.25. Ooh, goodness. Okay, I forgot. So I want you to try the next couple and then hit play to check your answers. I think there's only 3 to try. Here's the first one. Oh, let me get rid of this calculator so you can see this. Remember, you've got to read carefully. This one is not a solution. Here's your second one. Oh, that was the exact same as the example we did. Hopefully you recognize that. And then here's the third one. And that's the end of our problems dealing with whether or not a point is a solution. The final video for this review is going to cover pages 10 through 12, which is our exponent rules. I'll see you in that video.